Good evening. So here we shall solve some more JEE Mains previous year questions on the chapter Center of Mass and Collision. So any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them. And in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, please install our Sapience education application where we shall upload some important questions based on the previous year exam. Um, uh, the link of the Sapience education application has been provided in the description. So here it is told that a stationary particle breaks into two parts of masses ma and mb, which move with velocities v and vb respectively. The ratio of their kinetic energies is. There is a stationary particle. It breaks apart into two parts, two masses ma and mb, which move with velocities va and vb respectively. Ratios of their kinetic energies is. So now the initial initially it was at rest, so u equal to 0. So I can say ma plus mb into 0. Here we can apply the conservation of momentum. So that will be ma va plus ma vb, that is equal to 0. So therefore mb vb that is equal to mb vb equal to minus of ma va, minus of ma into va. So now therefore ratio of the kinetic energy is kb by ka. So kb will be half mb into vb square, and this will be half ma into va square. So half and half will get cancelled. So this will be mb vb square by ma va square into ma by mv. So ma va and ma vb square, that will be same only. So these two will cancel. So kb by ka, that is equal to ma by mb. By mb. And from here we can say that mb vb that is equal to ma va. So is that ma by mb, so that is vb by va. So it means this is also equal to vb by va. So it means option 1 is the correct answer. Then here it is told an artillery piece of mass m1 fires a shell, and artillery is it fires a shell of mass m2 horizontally, its mass is m1. Instantaneously after the firing, the ratio of kinetic energy of the artillery to that of the shell is. So suppose the shell will move with a shell. So that shell will move with a velocity v2, and m1 will obtain a recoil velocity v1. So here we have to apply conservation of linear momentum. So we can say m1 v1 plus m2 v2, that will be equal to 0, since why the artillery along with the shell was initially at rest only. Therefore I can say v2 equal to minus of m1 v1 by m2. We have to find the ratio of kinetic energy of the artillery, is k1, to that of the shell, that is k2. So k1 by k2, that value we have to find. So k1 is half m1 v1 square divided by this is half m2 v2 square. Half of will cancel. From here we can see m2 v2 equals to minus of m1 v1. Means what? We can write m1 v1 square by m2 v2 square v2 square into m2 by m1. So m2 v2 and m1 v1 will be same. Their square also will be same. So k1 by k2 that is equal to m2 by m1. So m2 by m1 is the answer. So option B is the correct answer. Then here it is told a spherical body is there. Its mass is 100 gram in 0.1 kg. It is dropped from a height of 10 meters from the ground. It is dropped from a height of 10 meters from the ground. After hitting the ground, the body rebounds. The body rebounds to a height of 5 meters. The impulse of the force imparted by the ground to the body is given by. The impulse of the force imparted by the ground to the body is given by. Impulse of force imparted by the ground to the body. Okay, this force you have to find out. So this force will be equal to the change in okay, this impulse of the force means F into delta T, which is a change in momentum that we have to find out. So it is mv final minus mv initial. Now v initial that will be equal to, so it is falling down. We can say v square equal to u square 0 square plus 2gh. So v equal to root over 2gh, and it is negative since why it is coming downwards, and it is going upward with a velocity, that is we can say v square, that is 0 square equal to u square minus 2gh. So u square will be also equal to 2gh1, where h1 is 5 meters. It means v final that will be equal to root over 2gh1. Therefore, the impulse of the force imparted by the ground to the body that will be equal to m mass is 0.1 into v final minus v initial. V final is root 2 gh1 minus of minus, so it will be plus 2 root 2 gh. So this will be 0.1 into root over 2 g is 9.8 into h1, that is 5, plus root over 2 into g 9.8 into h, that is 10. This is 10. Therefore, the impulse that will be equal to 0.1 mass into root over 2 5 is 10, so root over 98 plus this is 98 into 2, that is root over 196. Okay, so this is so 196 you can write, that is 98 into 2 means 49 into 4. So this will be 0.1 into is root over 49 into 2. So that this is 7 root 2 plus this is 7 into 2, that is 14. So this will be, this I can write 0.7 into root 2 plus 2. 0.7 into 2 plus 1.414, so 3.414 to 0.7. 3.414 into 0.7, so 7 4s are 28, 7 7 9, 7 4s are 28, then 3 7 21, 23. So this is 2.39 approx. So it is approximately 2.39 kg meter per second. So option B is the correct answer. Then it is told two bodies of mass 4 gram and 25 gram are moving with equal kinetic energies. The ratio of magnitude of their linear momentum is. The ratio of magnitude of their linear momentum is two bodies of mass 4 gram and 25 grams. Okay. So the ratio of their masses m1 is to m2, that is 4 is to 25. So now therefore ratio of their, they have equal kinetic energies, means k1 equal to k2. Now kinetic energy we know that is equal to p square by 2m. So therefore k1 equal to k2 means p1 square by 2 m1, that is equal to p2 square by 2 m2. Then ratio of magnitude of their linear momentum that we have to find, means p1 is to p2 value we have to find out. So 2 will cancel out. So p1 by p2 whole square, that is equal to m1 by m2, which is equal to 4 by 25. So therefore p1 by p2 will be the square root of this, so it will be 2 by 5. So 2 is to 5 is the required ratio. So option C is the correct answer. Then it is told a body of mass 1000 kg is moving horizontally with a velocity 6 meter per second. If 200 kg extra mass is added, the final velocity is. So here extra mass is added, but so the momentum will remain the same since no extra force is being exerted, no extra force is applied. So we have to apply the conservation of linear momentum, conservation of linear momentum of the object. So therefore you can say m initial v initial, that is equal to m final v final. So its mass is 1000 kg only, mass will not change into, okay, no, mass is changing. So 1000 v initial, the initial velocity is 6, and 200 kg mass, the extra mass is added, so it is 1200 now, into v final, the final velocity only we have to find out. So v final will be 6000 divided by 1200, so 0 0 will cancel, 2 5 is 60, so 5 meter per second. So this is the final velocity. So option D is the correct answer. Here it is told a uniform thin metal plate of mass 10 kg with dimensions is shown. The ratio of x and y coordinates, the ratio of x and y coordinates of center of mass of plate is n by 9. The value of n is. So the mass of this metal plate is 10 kg. The ratio of x and y coordinates of center of mass of the plate is n by 9. The value of n is. So XCOM by YCOM, the ratio of X and Y coordinates of center of mass of plate is n by 9. Then n will be how much? That we have to find out. So the center of mass of this part it is a uniform thin metal plate. So I can say uh, this part, for this part, the center of mass will lie exactly at the center, which is we know that the center, that is 0, 0, so it will lie at the y coordinate will be 1. This is 1, 2, so x coordinate is half. So at half, 1, the x coordinate of the center of at half, 1 is the coordinate of the center of mass of the part 1 of the region 1, I can say. And here it will lie at the center. This is 1 and 2, so this will be 3 by 2, x coordinate is 3 by 2. This is the center of mass C2 of this middle part. So x coordinate is 3 by 2 and the y coordinate is 1 by 2. And here also the center of mass C3, its x coordinate is 5 by 2, 2.5, and the y coordinate will be 1. So then the center of mass XM, that will be equal to, we know that summation AI xi by summation AI, which is equal to summation, so if which is equal to a1 x1 plus a2 x2 plus a3 x3, where x1 x2 and x3 are the center of masses for the regions 1, 2 and 3. So divided by a1 plus a2 plus a3. So XM, that will be area of this part, that is equal to length into breadth. Length, that is 2 units, and breadth is 1 unit, so 2 square units. So the area of the second part, that is length into breadth. Length is 1 unit and breadth is also 1 unit, so 1 square unit. And here A3 is the area of this part. So the area will be length, that is 2 units, and breadth, that is 1 unit, so 2 square units. 2 square units. So this will be A1 x1, which is 2 into half plus A2, 1 into 3 by 2 plus A3 x3, which is 2 into 5 by 2 divided by A1 plus A2 plus A3, which is 2 plus 1 plus 2. This will be 1 plus 3, that is 4, 4 plus 1 into 3 by 2. So okay, so this is 1 plus into 3 by 2. So this is 1 plus 1.5 plus 5 divided by 5. So this is 6 plus 1, 7 by 5 by 5. That is so that is 1.5, means 1.5 square units. Y coordinate of center of mass YCM, that is equal to summation AI yi divided by summation AI, which is equal to A1 y1, A2 y2, A3 y3 divided by A1 plus A2 plus A3. It is equal to A1, that is 2 into Y1, that is 1, plus A2, that is 1 into Y2, that is half, plus A3, that is 2 into Y3, that is 1, divided by 5. So that is plus 2, 4, 4.5, 4.5 by 5, that is 5 9 the 45, 0.9. So it is not square units, so it's much units. Okay. So x coordinate of center of mass by y coordinate of center of mass. So that is 1.5 divided by 0.9. So that is 15 by 9. So 15 by 9 is equal to n by 9 only. So n is equal to 15. So 15 is the correct value of n. And here it is told, in a system, two particles of masses m1 equal to 3 kg and m2 equal to 2 kg are placed at a certain uh, distance from each other. The particle of mass m1, so m1 and m2, they are kept at some separation, let's say x. This m1 mass is 3 kg and m2 mass is 2 kg. They're placed at a certain distance from each other. The particle of mass m1 is moved towards the center of mass of the system through a distance 2 centimeter. In order to keep the center of mass of the system at the original position, the particle of mass m2 should move towards the center of mass by the distance dash centimeters. So let's say L. They have to move a distance L. So that we have to, that's this L we have to find out. So if let's say m1 was initially at the origin at x equal to 0 and m2 was initially at x equal to, suppose, x naught. So their initial separation is x naught. So then the center of mass, x coordinate of center of mass of the system, that will be m1x1 plus m2x2 divided by m1 plus m2. So this will be x1 is 0 only, x2 is x naught. So that will be 3 into 0 plus 1 2 into x naught divided by m1 plus m2, that is 5. So this is 2 by 5 times x naught. Then y coordinate of center of mass, that will be equal to m1 y1 plus m2 y2 divided by m1 plus m2. Okay, so here y coordinate of center of mass is not required. So the x coordinate of center of mass should remain unchanged. So the x dash cm, the new value of the x coordinate of center of mass, now m1, the x1 dash, that is equal to 2 centimeter, and x2 dash, that will be equal to x naught minus L centimeter. And let's say x naught is in centimeter only. So then L we have to find out. So so if XCOM dash, that should be same as XCOM, means the center of mass of the system remains uh, unchanged. So in order to keep the center of mass of system at the original position, the particle of mass m2 should move towards the center of mass by the distance how much, that we have to find. So XCOM dash, that is m1 x1 dash plus m2 x2 dash divided by m1 plus m2. So that M1 is 3 kg, 3 into 2 centimeter plus M2, that is 2 into x naught minus L centimeter by 5. So that should be also equal to 2 by 5 x naught. Now therefore 2 by 5 x naught, that is equal to 6 plus 2 x naught minus 2L divided by 5. So 5 and 5 will cancel. So I can say 2x naught, that is equal to 6 plus 2x naught minus 2L. The 2x naught will cancel. So 2L equal to 6. So L will be equal to 3. So 3 centimeters. So it means the mass M2 should be moved towards the center of mass of the system by a length 3 centimeter. Then only the x coordinate of center of mass of the system will remain unchanged. So answer is 3 centimeter. Okay, so here it is told that if momentum of a body is increased by 20%, then its kinetic energy increases by. So it means, as we know, kinetic energy equals to p square by 2m. So now the initial kinetic energy, it was, let's say, p square by 2m only. Then the final kinetic energy will be, so now p has been increased by 20%. So the final momentum is P initial plus 20% of P initial. So that is 120%. So that is 1.2 times P. So the final kinetic energy will be 1.2 times P whole square by 2m, which is 1.44 P square by 2m. So it means it is 1.44 times the initial kinetic energy. So therefore the percentage increase in the kinetic energy, that is the final kinetic energy minus initial kinetic energy by initial kinetic energy into 100%. So that will be so 1.44 initial kinetic energy minus initial kinetic energy by initial kinetic energy into 100%. So that will be equal to 0.44 into 100, that is equal to 44%. So there is 44% increase in the kinetic energy. So option C is the correct answer. And here it is told two bodies of mass 1 kg and 3 kgs have position vectors I cap plus 2j cap plus k cap and minus 3 I cap minus 2j cap plus k cap respectively. The magnitude of position vector of center of mass of this system will be similar to the magnitude of the vector. So the magnitude of position vector of the center of mass of the system. Okay. So RCOM, that is the position vector of the center of mass, that is given as M1 R1 plus M2 R2 plus by M1 plus M2. Since why? Where R1 and R2 are the position vectors of the masses 1 kg and 3 kg. So M1 is 1 kg and M2 is 3 kg. So 1 into R1 vector. So this one is R1 vector and this one is R2 vector. So R1 vector, that is I cap plus 2j cap plus k cap plus M2, that is 3 kg, 3 into R2, that is minus 3 I cap minus 2j cap plus k cap divided by 1 plus 3, that is 4. So therefore we can say I cap plus 2j cap plus k cap minus 9 I cap minus 6 j cap plus 3 k cap divided by 4. So this will be minus 8 I cap, then minus 4 j cap, then plus 4 k cap divided by 4. So this will be minus 2 I cap minus j cap plus k cap. So this is the position vector. So this is actually minus 3. Okay. So the magnitude of this position vector that we have to find, magnitude of this position vector, that will be square root of 2 square plus 1 square plus 1 square, that is 1 plus 1 2 plus 4 is root 6 units, root 6 units. Now similarly root 6 will come for the first one, so option A is the correct answer. Since why, the magnitude of this vector will be same as the magnitude of the position vector of the center of mass of this system, which is root 6. Then it is told in two different experiments, an object of mass 5 kg, it is moving with a speed 25 meter per second, hits two different walls and comes to rest within 3 seconds and 2 seconds respectively. So it is a fixed wall, two different walls, and it comes to rest within uh, 3 seconds and 5 seconds respectively. Then choose the correct option of out of the following. Impulse and average force acting on the object will be same in both cases. So here the impulse will be change in mo momentum, the change in momentum, that will be obviously mass into initial velocity, since the final velocity is 0, since it is coming to rest at the final instant. So this much kg meter per second, so it is 125 kg meter per second. So the impulse is, it will be same in both cases, but the average force will not be same. The force exerted in case 1, that will be the change in momentum by time interval. So that will be 125 by 3, that is 3 fours are 12, 1 are 3.67, 41.67 Newton approximately. Approximately 41.67 Newton is the force in case 1, where the object comes to rest within 3 seconds, and F2 is the force that is applied in case 2, where the which is change in momentum by time interval, but here time interval is 5 seconds. So this will be 125 by 5, so that is 25 Newton. So 25 Newton is applied in both cases. So here we can say that impulse will be same for both the cases, but the average force exerted will be different. So the average force will be different and impulse will be same for both the cases. So option B is the correct answer. And here it is told a body of mass 10 kg is projected at an angle 45 degree with the horizontal. There is a mass, its mass m is 10 kg. It is projected. It is projected at an angle 45 degree with the horizontal. The trajectory of the body is observed to pass through a point. It is observed to pass through a point 20, 10. If t is the time of flight, then its momentum vector at time t equal to t by root 2. G equal to 10 meter per second square. T is the time of flight, then its momentum vector at time t equal to t by root 2 is the trajectory of the body is observed to pass through a point 20, 10. T is the time of flight, then its momentum vector at time t equal to t by root 2 is. So x comma y, it is, so x will be, so its initial velocity is u, suppose, and g is acting vertically downwards, that is 10 meter per second square. So x at any time, it will be u cos theta, means u by root 2 into t, and y will be u sin theta, means u by root 2 into t minus half gt square. So therefore, u by root 2 t is, so t I can say it is root 2 x by u. So y I can say that is x minus half g into 2x square by u square. 2 cancel. So y equal to x minus 10x square by u square. So this is y. So from here we can find out the initial, so it is the equation of the trajectory. Equation of trajectory. So here we have to find its momentum vector at time t equal to t by, so at t equal to t by root 2, the p vector that we have to find out. It means m v vector, where m is 10 kg. So 10 into v vector that we have to find out. So now y is, so at x equal to 20, y equals to 10. So therefore we can say y is 10, 10 equal to 20 minus 10 into 400, since 20 square is 400 by u square. So 0, 0 we can cancel. So I can say 400 by u square, that is equal to 2 minus 1, that is 1. So u square will be 400. So u equal to 20 meter per second. So the initial velocity is 20 meter per second. And t is the time of flight. So therefore the time of flight t will be equal to 2u sine theta by g. So that is 2u in 2 into u, that is 20 into sine 45 degree, that is 1 by root 2 into 1 by g, that is 10. So this is 2 root 2 seconds. 2 root 2 seconds is the time of flight. So therefore at t equal to t by root 2, that is equal to 2 by root 2 root 2 by root 2, that is at 2 seconds. You have to find what is the momentum vector. So then the velocity vector we can find. So that will be u x, that is u cos theta, that will remain same, I cap, plus this will be u sine theta, u minus gt, minus gt j cap. So v vector, so therefore velocity vector, that will be u, that is 20 by root 2 I cap plus 20 by root 2 minus 10 into 2 j cap. So this is 10 root 2 I cap plus 10 root 2 minus 20 j cap meter per second. So therefore now the momentum vector, which is mv vector at t equal to 2 seconds, that we have to find out. So that will be equal to m, that m we know mass is 10 kg, so 10 into v, that is 10 into 10 root 2 I cap plus 10 root 2 minus 20 j cap, and this much in kg meter per second. So this will be 100 root 2 I cap plus this will be 100 root 2 minus 200 j cap kg meter per second. 100 root 2 I cap plus 100 root 2 minus 200 j cap kg meter per second. So option D is the correct answer. And here it is told a ball of mass 0.15 kg hits the wall with its initial speed of 12 meter per second. There is a ball is there, its mass is 0.15 kg. it hits the wall. It hits the wall. This is the wall. So it hits it with an initial speed u, that is 12 meter per second, and bounces back without changing its initial speed. If the force so it means the magnitude of the final velocity will be u, but simply its direction will be opposite, since it is told it bounces back. If the force applied by the wall on the ball during the contact is 100 Newton, so it means the force applied by the wall, which is obviously an impulsive force, that is 100 Newton, then calculate the time duration of the contact of the ball with the wall. So for how much time the ball is in contact with the wall, that we have to find out. So the average force applied by the wall, that is change in momentum by time interval, and this time interval only we have to find out. So therefore time interval, that will be equal to the change in momentum divided the change in momentum divided by the force. So the change in momentum, that will be equal to mu minus of minus mu. Suppose we take the direction towards the left as positive, then obviously the direction towards the right will be negative. So this by the force is 100. So m is 0.15 kg. So this will be obviously 2 mu by 100. So therefore the time interval, that will be equal to 2 into m 0.15 into u, that is 12 by 100. This is 0.24 into 0.15. So this will be 15 for the 60. This is 15 for the 60 to the 30, 360, but 0.036. So it will be 0.036 seconds. So option B is the correct answer. Yeah, so here it has been told that two identical blocks A and B, each of mass m, resting on the smooth horizontal floor, are connected by a light spring of natural length L and spring constant K. A third block C of mass m, moving with a speed v along the line joining A, collides with A. The maximum compression in the spring is. So maximum compression will happen when they both will move with a common velocity. B and A will have the common velocity, let's say v1, after the collision. So therefore I can say that the linear momentum will be conserved for the system. So I can say mv, since the block C is initially moving with the speed v, and so they are kept, A and B are kept at rest initially. So mv, that is equal to 2m into v1 plus m into v2. So after collision, suppose we assume that the block C is moving with a velocity v2, and also uh, so initially the mass m of block A, it is at rest only. So actually when masses are same, then there is exchange of velocities. Mm. You can say that mv, okay, Suppose there is elastic collision, then we can say mv1 dash mv1 dash plus mv2, that is equal to mv, and E coefficient of restitution, that is equal to v1 dash, which is the velocity of block A just after the collision, and v1 is the velocity of A and B when there is maximum compression in the spring. So v1 dash minus v2 divided by v minus 0. So E is 1. E is equal to 1 is, since it is, if it is elastic collision, then we can say, since by maximum compression in spring will happen only when there is elastic collision. So v1 dash minus v2, that is equal to v. And from here we can see that m will cancel. So v1 dash plus v2, that is equal to v. So if we add them, then we will get 2 v1 dash, that is equal to 2v. So v1 dash equal to v. So it means v2 will be 0. So v2 will come to rest. Since when there is elastic collision, then there is exchange of velocities when the masses are same. So v2 will be 0. So we can take this v2 as 0 only. So therefore v1, that is equal to v by 2. v1 that is equal to v by 2. And now we can apply conservation of energy. So I can say half mv square, which was the initial kinetic energy of the system, that is equal to the final kinetic energy of the system, that is half into 2m into v by 2 whole square plus the compression in plus the spring potential energy, which is half kx square. We have to find the maximum compression in the spring. So half kxm square. So half and half, these will cancel out. So I can say kxm square, xm only you have to find the maximum compression in the spring. So kxm square, that is equal to mv square minus, this will be v square by 4. So this will be mv square by 2. So kxm square, that is equal to half mv square. So therefore I can say kxm square, that will be equal to half mv square. So xm square, that is equal to mv square by 2k. So therefore xm will be equal to v into root over m by 2k. So option D is the correct answer. Then here it is told a large block of wood of mass m is 5.99 kg, hanging along two massless cords, a bullet of mass 10 gram. So the mass of the bullet is 10 gram, means it is 0.01 kg, is fired into the block and gets embedded into it. The block plus bullet then swing upwards. Their center of mass rising a vertical di- distance h equal to 9.8 centimeter before the block plus bullet pendulum comes momentarily to rest at the end of its arc. The speed of the bullet just before collision is, so we can say here the kinetic energy, that is equal to the gain in the loss in kinetic energy equal to the gain in potential energy of the system. So loss in kinetic energy, that will be equal to half mv square, and that is equal to the gain in potential energy, which is m plus m into gh. So v we have to find out. So v square will be 2m plus m into gh by m. So v square will be equal to 2 into m plus m. So m plus m, if we do, then that will be 6 kg. So 6 into g, that is 9.8 meter square. H is 9.8 centimeters. So h will be 9.8 into 10 power minus 2 meter. 9.8 into 10 power minus 2 meter by m. M is 0.01 kg. This is 10 power minus 2. So this 2 will cancel out. So v square is equal to 12 into 9.8 whole square. So it means that v will be equal to 9.8 into 4 3 is 12. So 2 root 3. So v will be equal to 19.6 to the 16. 19.6 into root 3. Root 3 is 1.73. This much meter per second approx. So which is approximately equal to speed of the bullet just before collision. Six kg. So it is approximately 40 meter per second. So here none of the options are correct. Then here it is told 4 equal masses m each are placed at the corners of a square of length L as shown in the figure. The moment of inertia of the system about an axis passing through A and parallel to dB. So we have to find the moment of inertia of this system about an axis which is passing through A and parallel to dB. So about this axis, we have to find the moment of inertia. So that will be equal to mr square by 2, which is summation mr square, which is summation mi ri square. So this length is L root 2. So L root 2 by 2, this length is L by root 2. This length is L root 2, and this length is again L by root 2. M into L by root 2 whole square. M into L by root 2 whole square plus m into L root 2 whole square. Ml square by 2 plus ml square by 2 plus ml square into 2. So this is ml square plus 2 ml square. This is 3 ml square. So the answer is 3 ml square, which is option D. Given below are two statements. One is labeled as assertion A. Okay, so we have to find which one is correct. So the assertion A, it is told body P having mass m, moving speed u, has head-on collision elastically with another body Q having mass m initially at rest. If m is much less than m, body Q will have a maximum speed equal to 2u after the collision. So we have to find that. So the larger mass capital M is having speed u. It collides head-on with mass m, which is initially kept at rest u2, that is 0. So after collision, what will happen? We have to conserve the momentum of the system. So mu, that is equal to mv2 plus mv1. And then the coefficient of restitution, that is v2 minus v1 by u1 minus u2. So that is u minus 0. So E is equal to 1 for elastic collision. So therefore v2 minus v1, that is equal to u. And from here we can say that this m is much v2, I can say that is equal to v1 plus u. Therefore mu, that is equal to mv1 plus mu plus mv1. Therefore from here we can say m minus m into u, that is equal to m plus m into v1. So v1, that will be equal to m minus m by m plus m into u. Now m plus or minus m, that will be approximately equal to m only. Since since m, small m is much less than capital M. Therefore this you can say v1 will be equal to u. So v1 is equal to u. So therefore v2 will be equal to 2u. v2 will be equal to 2u. So hence the smaller mass will move with a velocity 2u after the collision. So it is true. So assertion is true. It is told during elastic collision, the momentum and kinetic energy are both conserved. Yeah, from this also we can find out, means we can say half mu square, that is equal to, using conservation of energy, that is equal to mv1 square plus mv2 square. And also we have mu, that is equal to mv2 plus mv1. And from here we got v1, that is equal to m minus m by m plus m into u. which is approximately equal to u only, since m is much more than m. v1 equal to u, so therefore I can say half m u square, that is equal to m, one is u, so m u square plus m v2 square. This is half m v1 square, half m v2 square. v1 is u, then these two will cancel out. Okay, no, half m v2 square, v1 square. So v1 square, that will be equal to m minus m by m plus m into u square. This is square, okay. So half, so from here m v2 square, that is equal to, I can say, m into u square minus v square, v1 square. So u square minus v1 square, that will be u square minus m by m plus m whole square into u square. So this will be u square into 4mm by m plus m whole square. So this is v u square minus v1 square. So m v2 square, that will be equal to u square into 4mm by m plus m whole square. So m I can cancel. So v2 square, that will be equal to u square into 4m by m plus m whole square. Now m plus m I can say it is approximately equal to m only. So therefore v square, that will be equal to u square into 4m by m square. So v2 is approximately equal to u by m, 2u by m. Okay. Since by v2 we got v2 is 2u here approximately. So it means that both A or R are correct, and R is the correct explanation of A. Option C is the correct answer. And here it is told that a circular hole of radius a by 2 is cut out from a circular disc of radius a as shown in the figure. The centroid of the remaining circular portion, the center of mass of the remaining circular portion with respect to O will be. So the center of mass of the original disk was at the center, which was at a comma 0, and this is at the center of mass of the cutout part, that is at a plus a by 2, that is at 3a by 2 comma 0. So here, since it is a uniform disk only, so we can tell the center of mass of the remaining part xum, the exponent of the center of mass of the remaining part will be somewhere here, xum comma 0. So that we have to find out, which will be equal to a1 x1 minus a2 x2 by a1 minus a2. So a1 is the area भैया थोड़ा सा ना स्मेल आ रहा है इधर से, पता नहीं क्या। So it will be uh, pi a square into x1, which is a, minus this part is pi a square by 4 pi r square into x2, that is 3a by 2 by pi a square minus pi a square by 4. So this will be pi a cube minus 3 pi a cube by 8 divided by 3 pi a square by 4. So pi a square part will get cancelled out. So pi a square, so this will be a, this will be a. So this will be a minus 3a by 8 by 3 by 8. So this, no, sorry, 3 by 4. By 4. So this will be 5a by 8 into 4 by 3. So this will be 4 to the 8, 5a by 6. So it means that it will be at 5a by 6. So option C is the correct answer. Then here it is told bullet of 10 gram, uh, bullet of 10 gram moving with velocity v collides head-on with the stationary bob of a pendulum. This 10 gram means its mass is 0.01 kg. Collides head-on with the stationary bob, which is velocity, initial velocity is 0, and recoils with a velocity 100 meter per second. So it will recoil, it will go backwards with a velocity 10 meter per second, 100 meter per second. The length of the pendulum L, that is 0.5 meter, and mass of the bob is 1 kg. And then the minimum value of V equal to how much, so that the pendulum describes a circle. So if the pendulum has to describe a circle, then we know the velocity at the lowermost point V1, that should be root 5 GL. Root 5 GL means it should be root over 5 into 10 into 0.5. It is 5 5s are 25, so root, so it is 5 meter per second. So then we have to apply conservation of momentum. So then we can say 0.01 m into v plus m, that is 1 kg, into 0, that is equal to 0.01 m into v, that is minus 100. Since after collision it is going backward, since it is telling that it recoils with a velocity 100, and plus m1 into 5. So 0.01 into v, that is equal to it is minus 1 plus 5, that is equal to 4. So it means v will be equal to 4 by 0.01. So it is 1 by 100. So it is 400 meter per second. So the bullet of mass 10 gram should have a minimum velocity of 400 meter per second. Then it is told body of mass 2 kg a body of mass 2 kg, its mass is 2 kg, it is moving with a speed of 4 meter per second. It makes an elastic collision with another body at rest. It is kept at rest. This is U1, this is U2 is at rest. So U2 is 0 and continues to move in the original direction but with 1/4 of its initial speed. So after collision, this object will have a velocity v2, v1 that is equal to 1/4 of this, that is 1 meter per second. The speed of the two bodies center of mass is. So this will move with the velocity v2. Speed of the two bodies center of mass. So the velocity of the center of mass that we have to find out. So velocity of the center of mass will remain unchanged. Since why there is no external force acting on the system, so the net momentum, the net momentum of the system will be conserved. So I can say that the velocity of the center of mass will remain same. So which is also same as, which is equal to mv1 plus m. So let's say this is m1. So m1 v1 plus m2 v2 by m1 plus m2, and which will be also same as m1 u1 plus m2 u2 by m1 plus m2. So after the collision also and before the collision also, the velocity of the center of mass will remain the same. So we can find VCM as the initial velocities we can use, and that is equal to x by 10. Then x value we have to find out. So velocity of the center of mass, that is m1, that is so there is elastic collision. So I can say E will be equal to V2 minus V1 by U1 minus U2. So for elastic collision, the value of the coefficient of restitution E, that is 1. So I can say V2 minus V1, which is 1 by U1, that is 4 minus U2 is 0, that is equal to 1. So therefore V1 minus 1, that is equal to 4. So V1 will be equal to V2 will be equal to 5. So V2 is 5 meter per second. So then their masses also we can find out. So M1 V1 plus M2 V2, that is equal to M1 U1 plus M2 U2 if we apply the conservation of linear momentum of the system. So M1 V1, M1 that is 2 kg into V1 that is 1 plus M2, which we don't know, we have to find out, M2 into V2 that is 5, that is equal to M1 that is 2 into U1 that is 4 plus M2 that is M2 into 0. So therefore we can say 5 M2 that is equal to 2 for the 8, 8 minus 2 that is 6. So M2 is 6 by 5 kg, which is equal to 5 ones of 5, 5 to the 10. So 1.2 kg. The M2 mass is 1.2 kg. So therefore velocity of the center of mass that we have to find out. Velocity of, here it is told, the speed of the two body center of mass. Therefore velocity of the center of mass, that is equal to m1 v1 plus m2 v2 by m1 plus m2. So m1 that is 2 kg, v1 that is 1 plus m2 that is 1.2 plus v2 that is 5 by 2 plus 1.2. So which is 2 plus 12 5 is 60. So 2 plus 6 by 3.2. is 8 by 32 into 10. 4 8 is 32. It's a 10. So it is equal to 5 by 2, which is equal to 25 by 10 meter per second. So which is equal to x by 10, that is told. So therefore x value is 25. The value of x is 25. And here it is told the position of the center of mass, the position of the center of mass of a uniform semicircular where the position of the center of mass of a uniform semicircular where of radius r. Its radius is r. So semicircular where, so its length is pi r, and it is placed in the xy plane. Its center is at the origin, and its center of mass will be somewhere on the y-axis. So, and the line joining its ends as x-axis is given by 0. So it is at 0 comma x r by pi. And the value of mod x we have to find out. So now semicircular where so since it is symmetric about the x-axis, so it will the center of mass will obviously lie on the y-axis, since the y-axis is a line of symmetry. Since we know that center of mass of any system should always lie on its line of symmetry only, and we have to find out the y coordinate of the center of mass. So y coordinate of center of mass, we can say that is equal to integral y dm by integral dm. Now the y coordinate, so if we take at an angle theta, if we go theta, and if we take a small element of length r rt theta here, then its x coordinate is equal to r cos theta, but its y coordinate is r sin theta. R sin theta, and then dm we can say that is equal to lambda into rd theta, where lambda is mass per unit length. Since it is a uniform where, so it is a uniform semicircular where, so the mass per unit length or the linear mass density is constant. The linear mass density, that is lambda, which is equal to dm by dl, that is equal to constant. So dm by dl will be equal to m by l only, m by l. So its mass is m. So lambda rd theta you can say. So this will be integral lambda r square sin theta d theta by integral lambda r d theta. And theta is going from 0 to pi. Theta is going from 0 to pi. So therefore this lambda r square will come outside, integral sin theta d theta, sin theta d theta, and that will go from 0 to pi, 0 to pi by lambda r integral d theta from 0 to pi. So this will be now lambda r will cancel, so it will come r into integral sin theta d theta, that is integral sin theta we know that is minus cos theta, minus cos theta, and it will go from 0 to pi. Pi, this will be pi only. So this is equal to r into, this is minus cos pi, that is now minus I can take outside. So cos pi minus cos 0 divided by pi. So this will be minus r into, this is minus 1 minus 1 by pi. So that is equal to 2r by pi. So 2r by pi, that is y coordinate of center of mass. Therefore, the coordinate of the center of mass, which is 0 comma xr by pi, that is nothing but 0 comma 2r by pi. So therefore, the value of x is 2. The value of mod x is 2. Absolute value of x. Then here it is told a rod of mass m. Rod of mass m and length L is lying on a horizontal frictionless surface. Horizontal frictionless surface. A particle of mass m traveling along the surface hits one end. It hits one end of the rod traveling along its surface. It's at one end of the rod with a velocity u in a direction perpendicular to the rod. The collision is completely elastic. Then after collision, the particle comes to rest. The ratio of masses m by m, that is equal to 1 by x, and the value of x is. So there is elastic collision, so it comes to rest. Then here it is told it comes to rest. So we can say so this is the center of mass here. So if we conserve the angular momentum of the system about this axis, then we can say, applying conservation of angular momentum, then we can say L by 2 into mu, it is mv into r, that is equal to, this will come to rest. So, and it will have some angular velocity omega, can say that is equal to I omega. About the center, that we know, that is equal to ml square by 12. Is there is no torque on the system, so angular momentum of the system is conserved about any point. So you can say ml square by 12 into omega. And it will have a velocity v also of its center. So you can conserve the kinetic energy also. We can say half mu square, that is equal to I omega square plus half mvcm square, half mv square collision, since this will come to rest. So then half I omega square. So from here, omega we can say that will be equal to 12 by ml square into L by 2 mu. So here we are applying the conservation of angular momentum of the system about the center of mass of the rod. Okay, so L will cancel, 2 6 are 12, so this will be 6 mu by ml. And if we conserve the angular momentum about this end of the rod, then we will get initial angular momentum that will be 0 and final angular momentum that will be, this will have some velocity v. Yeah. Oh. So here it is told that so the value of x to find out. So here we have to conserve the linear momentum also. So I will tell m into v, that will be equal to m into u. So therefore v will be equal to mu by m also. So therefore I can say half mu square. That is, so half or half I can cancel out also. So mu square equal to ml square by 12 into omega square. So omega square will be 36 m square u square by m square l square. So 12 3s are 36. So m will cancel, l square will cancel. Plus this is mv square. So m into mu by m whole square. So therefore from here I can say mu square, that is equal to 3 m square u square by m plus m into m square u square by m square. So m will cancel out. So this will be mu square, that is equal to mu square by m plus 3 m square u square by m. So this is 4m square u square by m. So m will cancel out, u square will cancel out. So I can say m by m, that is equal to 1 by 4. So that, which is equal to 1 by x. So therefore x is equal to 4. The value of x will be 4. Then here it is told the projectile motion of a particle of mass 5 kg is shown in the figure. The initial velocity of the uh, particle is 5 root 2 meter per second. Initial velocity u, that is 5 root 2 meter per second, and the air resistance is assumed to be negligible. The magnitude of the change in momentum in between the points A and B is the magnitude of the change in momentum in between the points A and B is x into 10 power minus 2 kg meter per second. The value of x to the nearest integer is. So here also the velocity will be u equal to 5 root 2 meter per second. So it means this way it will be u cos theta. This is theta, which is 45 degree. So cos theta is 1 by root 2. Cos 45 is 1 by root 2. Cos 45 degree, that is equal to 1 by root 2. So therefore I can say that this component will be 5 meter per second, and the vertical component will be also 5 meter per second, which is u sine 45. And here also this way it will be u cos theta, that is 5 meter per second, and the vertical component also will be u sine theta, which is 5 meter per second. So along the x-axis there is no change, therefore the change in momentum, its magnitude we want, that will be equal to 5 minus of minus 5 uh, meter per second, which is into the mass. Mass is 0.005 kg. So this will be 0.005 into 5 plus 5, that is 10. So this is 0.05 kg meter per second, which is actually 5 into 10 power minus 2 kg meter per second. Kg meter per second. So therefore the value of x is 5. The value of x is 5. 5 is the answer. Then here it is told that a ball of mass 10 kg moving with a velocity 10 root 3 meter per second, 10 root 3 meter per second along the x-axis, it is moving with 10 root 3 meter per second, hits another ball of mass 20 kg which is at rest. 10 root 3, it is moving and it hits another ball of mass 20 kg which is initially at rest. Its mass is 10 kg. After the collision, first ball comes to rest. First ball comes to rest. While the second ball disintegrates into two equal pieces. One piece starts moving along y-axis with a speed of 10 meter per second. One piece, two equal pieces. So each piece will have 10 kg mass. And the second piece starts moving at an angle of 30 degree with respect to the x-axis. The velocity of the ball moving at 30 degree with x-axis is x meter per second. So v2 is actually x meter per second. The configuration of the pieces after collision is shown in the figure below. The value of x to the nearest integer is. So the linear momentum will be conserved along the x-axis. So I can say that 10 root 2 into 10 m1 into u1, that is equal to this m is 10 and into this is V2, which is x cos 30, x cos 30. So x we have to find out. And also we can say 10, 10 into 10 root 3, sorry, this is 10 root 3. This is 10 into this x. 10 into x sine 30, that is equal to 10 into 10. 10 and 10 will cancel. So x by 2, that is equal to 10. So x will be equal to 20. Now 10 and 10 will cancel and cos 30 is root 3 by 2. So x into root 3 by 2, that is equal to 10 root 3. Root 3 roots will cancel, to x is 20. So therefore the value of x is 20. So 20 is the answer. Here it is told disk of mass m. Disk of mass m with uniform surface density sigma. Surface mass density sigma. So sigma is mass by area. The center of mass of the quarter disk is at the position x root xa by 3 pi comma xa by 3 pi. So it is at xa by 3 pi comma xa by 3 pi, xa by 3 pi, where x is so much. So here so x coordinate of the center of mass, we can say x coordinate of center of mass, that is equal to actually integral x dm by integral dm, and y coordinate of center of mass, that is equal to integral y dm by integral dm. Now dm, that we can say now, or we can say first we can find out for a ring. So it will be obviously at y equal to x. Now if it is a quarter ring, so for quarter ring, if we want to find center of mass, then we will do at an angle theta, we will take a small angle d theta, where a small line element will take dl, that is equal to r d theta. So mass, so dm, that will be equal to lambda dr, lambda dl, that is lambda r d theta, and x coordinate of center of mass, that will be equal to your x coordinate is obviously r cos theta, so which is integral r cos theta into lambda r d theta from 0, where theta will go from 0 to 90 degrees, that is pi by 2, divided by integral dm lambda r d theta from 0 to 2 pi, 0 to pi by 2. So this will be lambda r square is common, and integral cos theta d theta from 0 to pi by 2 divided by lambda r into pi by 2. So lambda r, this will cancel. So this is 2r by pi into integral cos theta d theta, that is sine theta. Sine theta will go from 0 to pi by 2. So sine pi by 2 is 1. So it is 2r by pi. So for a ring, for a quarter ring, the center of mass will be obviously located at 2r by pi comma 2r by pi. Now we have um, have a disk here. Therefore, for disk, the x coordinate of center of mass, that will be integral. So here actually we can consider the quarter disk as quarter disk. We can consider it as a collection of some rings. It is a collection of some rings where r, small r, will go from 0 to r. 0 to r. So now so here d L, that will be so dm that will be equal to sigma into dA, sigma into dA, sigma into dA will be pi by 2 into r, pi by 2 into r, the length into thickness, that is dr. And for this, the x coordinate of center of mass, that will be at x coordinate of center of mass, that will be at 2r by pi, 2r by pi. So x coordinate of center of mass for the disk, if we have to find, so that will be x coordinate of center of mass for the ring of width dr by integral dm. So that is, and here r will go from 0 to r, 0 to r. So this is obviously 2r by pi into dm, that is sigma into 2 pi 2 there is pi r by 2 into dr divided by 2 r sigma into pi r by 2 into dr. Sigma into pi r by 2 into dr. Okay, integral. So this 2 will cancel, pi will cancel. So it is sigma will come out into r square dr from 0 to r divided by sigma pi by 2 integral r dr, so 0 to r. So this will be sigma will cancel out. So this is 2 by pi into r square dr is r cube by 3. So it is r cube by 3 divided by, this is r square by 2. So this will be equal to 4 by pi r 4 by pi r square. 4 by pi r square into 3 into r cube r square. So it is 4r by 3 pi. 4r by 3 pi. And the radius has been told it is a. So it will be 4a by 3 pi. 4a by 3 pi. So which is equal to x a by 3 pi. So therefore x will be equal to 4 here. X will be equal to 4 here. Then here it is told a ball of mass 10 kg moving with a velocity 10 root 3 meter per second along the x-axis hits another ball of mass 20 kg which is at rest. Here 20 kg ball which is at rest, and here 10 kg ball is there which is moving along x-axis at 10 root 3 meter per second. After collision, the first ball comes to rest and the second one disintegrates into two equal pieces. Each one is of mass 10 kg. One of the pieces moving along y-axis is at a speed of 10 meter per second, and the second piece starts moving at a speed of 20 meter per second at an angle theta with the x-axis. The configuration of pieces after collision is shown in the figure. The value of theta to the nearest integer is. So here the momentum will be conserved along x-axis. So I can say m into v, that is 10 root 3, that is equal to m 10 into v, that is 20 cos theta. And also we can say m into v sine theta, that is equal to m into v. So here also 10 cancel, 0 cancel, so cos theta is root 3 by 2. And from here also we will get sine theta is equal to 1 by 2. So therefore angle theta is 30 degree. So the value of theta is 30 degrees. Then here it is told two particles having masses 4 gram and 16 gram respectively. One is having mass 4 gram, means 4 gram, and another is having mass capital M, which is 16 grams. So it is actually equal to 4 times of M. It is moving with equal kinetic energies. So they are having equal kinetic energy, K1 equal to K2. Then the ratio of the ratio of the magnitudes of their linear momentum is n is to 2. So it is told P1 is to P2, that is equal to n is to 2. The ratio of their momentum is n is to 2. Then the value of n will be. So kinetic energy 1, that is we can say P square by 2m1, that is equal to P2 square by 2m2. So therefore we can say 2 will cancel out. So then we can say P1 square by P2 square, that will be equal to m1 by m2. So therefore P1 square by P2 square, m1 is 4 gram and m2 is 16 gram. So 4 is 16. So therefore P1 by P2 will be equal to 1 by 2. So which is equal to n by 2. So therefore n will be equal to 1. Therefore the value of n is 1. 1 is the answer. And here it is told two solids A and B of mass 1 kg and 2 kg respectively are moving with equal linear momentum. The ratio of their kinetic energies Ka is to Kb will be A is to 1. So the value of A will be. So they are having equal linear momentum, P1 equal to P2. So P1 square will be equal to P2 square. So I can say P1 square is 2m into kinetic, 2m1 into kinetic energy of A. Ma into kinetic energy of A, that will be equal to 2mb into kinetic energy of B. So 2 and 2 will cancel out. So kinetic energy of A by kinetic energy of B, that will be equal to mb by ma, which is equal to 2 by 1. So therefore the value of A will be 2. So 2 is the answer. Then here it is told a ball is moving with a speed of 9 meter per second. Its mass is m. It collides with another identical ball of mass m, which is at rest. So it is at rest, u2 is 0. Then after the collision, the direction of each ball after the collision the direction of each ball after the collision, it will collide. uh, After collision, the direction of each ball makes an angle 30 degree angle of 30 degree with the original direction. So after collision, m1 m2, so they are having same mass only. So they are moving at an angle of 30 degree with the original direction. 30 degree, m and m. Then this is v1, this is v2. The ratio of the velocities of the balls after collision is x is to y, where x is. So the ratio of their velocities means x1 means v1 is to v2, that is equal to x is to y. then x will be how much? So here we can say, if we apply conservation of linear mo momentum along y-axis, and we have to conserve linear momentum of the system along x-axis also. So therefore I can say that v1 sine 30, that is equal to v2 sine 30. Since why this will be v1 sine 30, this will be equal to v2 sine 30, and that they should cancel out. So therefore sin 30 cancel. So v1 will be equal to v2. So v1 and v2 are same. So let's say we can take them as v and v. So I can say them that v cos 30 into 2, 2v cos 30. And here also m and m should be there since their masses are same. So m and m also will get cancelled. mv1 equal to mv2. So m and m will cancel. So v1 equal to v2. And let's say we take them as v, suppose. So 2mv cos 30, that is equal to m into u, if we conserve the linear momentum along the x-axis. So m will cancel. So therefore 2v cos 30, that is root 3 by 2, that is equal to u, that is 9. So v equal to 9 by root 3. So I can say v will be equal to 3 root 3 meter per second. V is equal to 3 root 3 meter per second. Then the ratio of the velocities of the balls after the collision. So obviously v1 and v2 are same, so it will be 1:1. So the value of x is 1. So hope all of you have understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter Center of Mass and Collision. Still any doubts if you have, please write that in the comments. We shall obviously clarify them, and please install our Sapience education application, whose link has been provided in the description, where we shall upload some important questions which shall be helpful for your exam. So thank you everyone. Bye.